Hello everyone, I am Dr. Jyoti Mandala. Welcome you all to the video lecture series on the course Operating Systems. We are in our lecture number 13. Up to our last lecture, we learned about what actually a process is. We understood what are all the different states a process has to go through, and we also understood like when a process has been copied from the secondary memory to the main memory, what sort of information has to be stored in the main memory, which is in the form of process control block. We also understood like during this process what are all the different types of queues has to be maintained, and we understood that is our last lecture. We understood like what are all the different process operations, like how a process can be created, what are all the different system calls to be used for that, and also we understood like how a process can be terminated. I hope you all are clear with those lectures. So in today's class, let us understand about inter-process communication. Now what actually this inter-process communication is? Inter-process communication is, we already know we are in our multi-processing environment where the CPU will be switching between multiple processes. So we will be having more than one process in our main memory, isn't it or not? In that case, there may be some scenarios where one process wants to communicate with the other process. In that case, now one process, if they want to communicate with the other process, how they will be communicating, that is what we are going to understand today, and what are all the advantages of happening that, and we will also understand how this inter-process communication will occur, like what are all the different ways we have to understand these two understand the inter-process communication. Okay, so let us understand first what are all the advantages of this inter-process communication. Keep your heading, all of you, advantages. So I will be listing out the advantages here. The first advantage is information sharing. So what is this information sharing? I'll write down the list here, and then you can just understand. We'll have a discussion in detail about what all these advantages are. So keep your heading, all of you, advantages. So as a shortcut, I will be writing as in IPC, inter-process communication. The first advantage is, as I already told you, it is used to achieve the information sharing. Like one information, I'll explain information sharing. Like suppose whatever the information that has been under the control of one process, if another process wants to use the same thing, then through this inter-process communication they can share that information. That is the first advantage, which will be mostly using that also. That is called as inter-process communication. And the second advantage is modularity. Modularity is nothing but, suppose a complex task is there. Now, if there is a provision to divide that big task into a simple task, and where an individual task can be taken care by the individual process, then the burden of doing the same task by one process has been reduced. So, modularity can be achieved by using our inter-process communication. Next one. Next advantage is computational speed up. What is this computational speed up? As we already understood, because of this modularity, the workload will be reduced. Then all the processes may be communicating or may be working parallelly at a particular time. Then the amount of time required to finish that task can be reduced. So that is why it is called as computational speed up. Computational speed up is nothing but the time required to finish your task can be less if the work has been divided into modules and can be assigned to multiple processes. And one more advantage I want to highlight here is, that is the fourth advantage, convenience. What is this convenience? Convenience is, it will be very easy for us to work with the process if there is a communication between one process to the other process, if it is not like everything should be available with that process. So it will be convenient for us to work with the process if there is an inter-process communication between the processes. So these are some of the advantages that has been highlighted in this slide. You can go through that one. I'll read out once again: information sharing, modularity, computational speed up, and convenience. Right? Now, what are all the different ways of we have to achieve this inter-process communication? So let us understand the different ways of inter-process communication. So keep your heading, all of you. So whatever the way we are adopting, those ways will be having these 4 advantages, whatever we have learned now. So keep hearing all of you. We have 2 ways of inter-process communication. First way, just 2 ways. First way we can achieve by using shared memory, and the second way by using message passing. So the first way, we have 2 ways of inter-process communication, shared memory and message passing. So let us understand in detail about all these 2 types. So first we'll understand what is this shared memory. Using this shared memory, how we are going to achieve the inter-process communication. So keep hearing all of you, shared memory. So as the name itself, it is suggesting shared memory. What do you mean by that one is, there will be a common memory space available in our main memory. Okay, and that common space will be shared by all the process. Now if any process wants to communicate with another process, then the process, let us consider process P1 and P2. Let me represent with one diagram. Let us consider this is actually our memory. Okay, and in this memory what happens, let us consider this is our memory. Now in this memory, some part, let us consider this is process P1 part. Okay, this is the user space. Normally what happens now, the main memory will be divided into 2 parts. I'll just note down that. The first space, let us consider this is called as user space, and another part, same kind, like we will have this memory, second part will be considered as a kernel space. Now what actually this kernel space is, kernel space will have the operating system related data. Okay, so whatever the software is related for the operating system, that will be stored in the, that should be available in the main memory. We already learned all these things. What is the use of having that in the main memory? Because the operating system has to run in the background. Now if you want to run that one, which is a software, that has to be available in the main memory. So that has to be stored in a space called kernel space, and it is also available in the main memory. Okay, now in the user space, what are all the processes the user is running, right? That will be stored here, all the programs and all. So let us understand, let us consider one process which is called as process P1 here. Here we will have P1, let us consider. Okay, and then we have, let us consider one more process is also there, and that process, let us consider process P2. Okay, here I will be representing that one, process P2. Okay, now let us consider that as P2. Right, now there is a small area in our user space which is called as a shared space. Now let us consider this is our shared space. Okay, I'll just highlight with another color so that it will be clear to you all. So let us consider this is some space where, which is called as a shared space. Okay, so this is called as our shared space. I hope you all are understanding. Right, I'll just represent this one. So this is our shared space. Oh, sorry. Okay, I hope you all are understanding. So this space is called as shared space. This space. Now what happens here, whenever a process wants to communicate with another process, in this case what happens, let us consider P1 wants to communicate with P2. In that case what happens, P1, whatever data it wants to communicate with P2, that will be stored in this shared memory. This is our shared memory. Okay, now the P2, it will be not in direct communication with the P1, it will be in contact with the shared memory, and it can get the data from that shared memory. That is how the shared memory will help us in getting the 2 processes communicate with each other. You need to understand here, there is no concept of system call here. You already know what is system call. System call is nothing but some predefined functions concept as the C programming language. Like the predefined things, functions will be there where we can make use of those things and we can get our work done. But if you are using a shared memory concept, there is no concept of system calls. Directly the data should be available, kept here by that process, and the another process can get the data from here. This is how shared memory will work. So to understand this one, let us take one example. That example, the famous example for this one is the producer consumer problem. Let me write here. So keep your heading all of you, producer consumer problem. So to understand the shared memory, we will do that one. Okay. So producer consumer problem. Now what is this producer consumer problem? Producer consumer problem is nothing but there are two parties involved here. The first party is called as a producer and the second party is called as a consumer. Okay, now what is the use? The first party is called, is represented as P. Let us consider producer. What is the task of this producer? The producer will be producing the item. Now we have another party who is called as a consumer. What is the work of the consumer is he will be consuming the item. Now to make them interact, like producer will be producing that item and consumer has to consume the item. Now there will be one location where the producer keeps the data there, and from that location only consumer has to take the data. Right. Now the simple task here, what we will be doing is we will be having one buffer where in this buffer, let us consider the buffer is of limited size. Okay. Now in this buffer, the producer will be inserting the data into that one, and from this one the consumer will be taking that one. Now this is our shared memory here. So whatever the buffer we are considering, this is our shared memory now. Okay, now how it is working, how they have programmed it. So to program this one, let us consider C programming language because we all are familiar with that. Now how they have programmed this one, how the producer and consumer are working together is, to understand this one, let us consider the two variables. First variable is in, second variable is out. Now what is the use of the in variable is, in variable will point out to the first free location, or you can say first free position, or I will say next free position. So wherever the free position is there which has been pointed by the in, there only the producer can place his item into that location. Okay, now out is used by the consumer where the consumer can get the data. So out will be represented by first fill position. That means that item is available there, you can get the data. Right. So to make you understand this one even more clear, let us write down the code first and it will be, let us understand this one. Okay. Now what is the task of the producer and what is the task of the consumer? This has been clearly mentioned here. Okay. So let us see that. So I will write here. First one is producer task. Now what is the use of the producer task? Now in the producer task what happens is, we all know, let us consider one condition, while true. While, I will just change the color so that you can understand this even more clear. So while true, I will be just writing what are all the tasks to be done by the producer. The first task will be while, you all know, not here. While we need to check there is some free slot is there or not. If free slot is available, then only producer can insert the data into that buffer, isn't it or not? To check that one, if we know the position of the next free location is pointed by the buffer, by the variable in. Okay, in plus 1. Okay, And here we will be having one more variable which is called as a buffer size, which holds the number of slots that buffer is having. Let us consider one example, 3 slots. Then only 3 values can be inserted into that buffer. If you have 5, then 5 values can be inserted into that buffer. Okay, in +1. Now what I am doing, after incrementing this one, I'll be just performing a modulus operation with that buffer size. Now what is the use of this one? I'll let you know with some example. Buffer size, okay, is equal to out. That means after incrementing, you are positioning to the same location where out is already there. In that case, it means the buffer is already filled and you should not do anything. So for that, I am putting semicolon. You all might be understanding. If this condition is true and if there is a semicolon, it will be in the infinite loop. Only when this condition becomes false, it will come out of this loop. At that time, what I am doing, I will be writing, let us consider that buffer, whatever we are saying, that buffer let us represent with a buffer array. Okay, now buffer of I want to store whatever the item has been produced by the next item. I'll write like this, or else I'll write produce next produce. Whatever has been produced by the producer, let us consider he has stored in a variable called next produce, that will be stored here, and I value should be incremented because it has to point to the next free location, right? So n is equal to n +1 modulus of buffer size. Right? This is the code for your producer. This is the work that has to be done by the producer. I hope you all are understanding. We'll take one example, then we'll understand clearly also. Okay. Let us consider the consumer task also, and let us write down the consumer task. Then we will see how it is working. Okay. Now what is the use of the consumer? If no items are there in the buffer, like if the buffer is completely empty, that we need to check, right? So in the producer case, we have checked the buffer is completely filled or what. If it is filled, we cannot push any element into the buffer. In that case, the producer has to wait. Now in the consumer case, if the buffer is free, then the consumer cannot take anything from the buffer. In that case, the consumer has to wait. For doing that task, we need to have a condition checking, where the condition checking is very simple. What is that? In equal to out. If in equal to out, that means the position of in and the position of out both are positioning to the same location. That means nothing is there in the buffer. Then in that case, the consumer has to wait. But if that condition is false, that means at least one item is there in the buffer. In that case, whatever is there in the buffer, get it and then store it into the next consume variable. Get it from the buffer and store it in the next consume. And after that, what we need to do? We need to increment our out variable because it has to point to the next free location. Right, this is the work of the consumer. So let us understand this one clearly with an example. Okay, so this is the work of the producer, this is the work of the consumer. Okay, so to understand this one clearly, let us take one example. I'll take an example of let us consider a buffer, this one, okay, whose size is of 3. That means the buffer size variable, the value is, this one is 3. So buffer size is equal to 3. And because this is an array, I let us consider this array is of buffer. That is what we have written in our code. So buffer, this is an index of 0, 1, 2. Okay. Initially, the in value and the out value should be represented with 0. The initial value should be 0. So in will be representing here and out also will be representing here. I hope you all are understanding. Now what we need to check. Suppose first only the consumer has started his work. Let us consider. In that case, the consumer, what is its task? Always it is true. So he will enter into this while loop. Now here we are checking in equal to out. S in equal to out only, we got the same value. In value is equal to 0. What I will do? In value is equal to 0 and out value is also 0. That means the condition is true. The consumer has to wait. That is what. So it is working. That means because no items are there for the first time, the consumer has to wait. Right. Now let us consider the producer wants to insert some item into the buffer. Whether it is working or not, let us see. Now what happens? The first, it is always true. Okay, so this he will enter into this one. Now while in plus 1, what is in plus 1? 0 plus 1. 0 plus 1 is 1. Modulus of, what is the buffer size? 3. What is 1 mod 3? 1 only, is equal to what is out value? 0 is equal to 0, which is false. In that case, what happens? It will come out of this loop and it will execute the next statement. What is the next statement? Whatever you have produced, let us consider the producer has produced the item of value 10. Then that 10 has to be stored in buffer of what? 0. In value is 0. So here we are storing our value, that is 10. Okay, then after that we are updating our in value. The in value will now come here. This is our in value. Now you might be getting a doubt why I am doing modulus of buffer size. There is a reason behind that. You might be knowing about circular queues, right? Now once you reach this location, then instead of we need to go back to this position, isn't it or not? So let us consider the elements are 3. 3 modulus 3, what is that one? 0. So we need to go back to this 0th location. Are you understanding? So that is the reason why we are doing with the modulus operation. I hope you all are clear. Now this is how the producer and consumer are interacting with each other using a shared buffer which is a shared memory concept. Okay, this is how the shared memory works. This is one example of that one. I hope you all are clear with this one. Right, now what we'll see, we'll go with the second type. What is the second type? Our second type, we already understood about this shared memory. I hope you all are clear. Now let us understand about this message passing. Now what is this message passing? How it will work? We'll see now. Okay, so keep heading all of you. Message passing. Now this message passing is very simple. In this case, there is no concept of shared memory. Now what actually happens is, let us consider this is your memory. Okay, in this is the user space and let us consider this is the kernel space. So let us not bother about this kernel space. Why? Because in the kernel space the operating system related data will be stored, right? In the user space, let us consider we have got two processes, same like earlier only. Let us consider process P1 and let us consider process P2. Okay, so let us represent that one. Let us consider this is process P1 and this is process P2. Now if process P1 wants to send any message to process P2, now there is no concept of shared memory. Then what it will do, process P1 will send that message to the kernel first. Okay, let us call that is the message. Okay, from here the process P2 will be getting the message. So there is no direct communication here also. The process P1 will be sending the data, whatever they want to communicate, to the kernel space. This is our kernel space, this is our user space, and from that space only, from that kernel space only, this is called our message, the process P2 will be getting the data. Right? I hope you all are understanding. So this is how. Now whenever we are talking about here, we need to consider about three issues. What are the three issues? Let us see. The first issue is naming. Okay, whenever you are talking about naming, let us consider process P wants to send some message to process Q. Okay, so in naming we have two approaches. What are that? Direct communication. What do you mean by direct communication? And we have another one is indirect communication. What is this indirect? We will see. In direct communication, if P wants to send any message to Q, they will be using the system calls. What kind of system calls? Suppose P wants to send any message to the, so P is our sender here and Q is our receiver. Okay, so now P, what it does, it will say send, okay, and the system call is send, and it will tell to whom it has to be sent, the receiver message, and the message whatever you want to send, that has to be passed here. So the system call that we are using, that the sender has to use, is send. Similarly, Q, what he will do, he will use receive system call, and he will mention from which receiver is expecting the message, and then whatever message he is getting, that will be stored in this variable, right? So in this we are mentioning the sender and receiver names, that's why it is called as direct communication. But whereas coming to the indirect communication, there in this also we are going to use the system calls, but we are not representing the sender and receiver name. What we are doing is the P, if he wants to send any message to Q, if sender wants to send any message to the Q, there is a space which is called in the kernel, which is called as mailbox. That is what I have represented here. Okay, now P will be sending the message here and Q will be getting the message from here. Now how they will be representing this one? P will be writing send mailbox and then message, right? Q will be writing receive mailbox and then message. This is how. So here it is an indirect way of communicating, where here we are representing the names directly, that's why it is called as direct. So this is the first one. Now let us see the second one, second issue. What is the second issue? Synchronization. How the synchronization happens if two process wants to communicate. Synchronization can be of first one is blocked way. What do you mean by blocked way is, that means blocked sender or blocked receiver. What is the meaning of this one is, suppose sender sends any message to the receiver, then until and unless the receiver receives that message, the sender cannot send any other message. That means the sender will be blocked from sending a new message. Whereas we have the other way, which is called as unblocked sender or receiver, where there is no blocking mechanism available here. The sender can keep on sending the messages, and whenever the receiver is free, he can get the data, right? Now this blocked way is called as synchronous way, and this way is this way of unblocking the thing, that means unblocked sender or unblocked receiver, is called as asynchronous way. Okay, you might be seeing our Gmail account or what, where we may be getting our mails dumped into our inbox. So whenever we are free, we are reading that message. That is one way of unblocked one, right? So this is the second issue. And the third issue is we need to talk about is the buffer size. Buffer size, we have three options: limited, two options are unlimited. Limited is nothing but the buffer size is of we will have, let us consider 25 GB of buffer space. Now up to 25 GB of data can be sent by the sender. Even if receiver is not receiving the data, it will be there. Now once the memory space has been reached, then the sender cannot send any new message. That is what happens with our Gmail accounts and all. So unlimited is nothing but, as the name itself it is telling, there is no concept of limit there. Unlimited space will be provided. The sender can keep on sending the messages. We have a third way, that is called a zero buffer. Zero buffer is nothing but, there is no concept of buffer. The sender, once it is sending, it has to be immediately taken by the receiver, otherwise the message is gone, right? So these are the three issues that we need to take care whenever we are bothered about using this message passing, right? So these are all the different ways of interprocess communication. I'll just quickly revise this one. We understood what are all the advantages of inter-process communication. Like we understood 4 advantages: information sharing, modularity, computational speed up, and convenience. We understood how message passing can be done. We understood shared memory and message passing. We understood how inter-process communication has been done. We understood it can be done in 2 ways: shared memory and the message passing. Shared memory we understood with one example, producer consumer process. And if you are adopting for the message passing, we need to take care of 3 issues, right? That's all as part of this inter-process communication. I hope you all are clear with this today's lecture. Let us all meet in the next lecture. Until then, thank you all of you.